between those elements which have more than 4 valence electrons. So we'll say it is generally found between two nonmetals which have 4 electrons or more than 4 electrons in their valence pair, and it is formed by the mutual sharing of electrons. Okay, the atoms which are involved in covalent bond formation, they usually share their electrons. We can neither gain or lose. And the number of electrons that is shared between them, that is known as covalency. Okay, so the covalency is achieved by both the atoms by mutual sharing of electrons. Okay. Now next we have non-polar covalent compounds. Non-polar covalent compounds. Okay. The covalent bond is found between two similar nonmetals. Okay. Similar nonmetals. Sometimes we have different nonmetals also. Okay. And when the electronegativity difference. Okay. Here electronegativity difference is very important. When the electronegativity difference between the two combining atoms is zero, is almost equal to zero or nearly them, then they form non-polar covalent bonds. And when the electronegativity difference is very high, okay, or there are some little, okay, there are little amount of electronegativity difference between them, then it is polar. And when the electronegativity difference is very high, that is one atom is highly electropositive and the other one is highly electronegative, then we say that it is equivalent in nature. So this is what covalent bond, which is found between two metals by mutual sharing of electrons. So I have some points for you, so please write it down. Yes, yes, Kundalia, you want to say something? Hello, yes. You want to say something? Okay, can you all see my screen?
Yes, sir.
Yes, sir.
Please take it down. Take down all the points regarding covalent bonds.
Sir, please show the previous slide. What was it?
It's like what I taught you in the previous one. This one. I think this is the first class. Okay, first online class with you. Or?
Yes, sir. First online.
Yeah. Those things I taught you in the classroom. I taught you about the characteristics of electrovalent compounds. Okay, those I'll give you again. Those points again you will get. Okay, so please complete this one. Those points again you will get. That will be under comparison. So please take it down. And write in your chemistry notebook. Okay, put the date and write in chemistry notebook because later on it will be asked for correction. Please write quickly.
Yes, sir.
Okay, next one. Distributed unequally. That means the shared pair of electrons will move slightly towards one of the atom, which is electronegative in nature. And because of that, charge separation will take place. For example, in hydrogen fluoride, okay, hydrogen fluoride it is covalent in nature, but it is polar covalent because chlorine is more electronegative than hydrogen, so it will pull a shared electron pair for itself. Because of that, chlorine will develop a slight negative charge and hydrogen slight positive charge, and it will become polar in nature. Okay. So covalent compounds are said to be polar when the shared electrons are unequally distributed between the two atoms. Okay, charge separation takes place between them, and okay, so that is because towards a more electronegative atom. Then this line is very important. The fourth one, the bond between two atoms with same electronegativity is non-polar. So when the two atoms have same electronegativity, then it is non-polar, and with slight electronegativity difference it is polar, and high electronegativity difference it is ionic in nature. Please write it down. then please mark the attendance also. Please open. Mark attendance. Okay, is it done? Have you completed this slide? Hello?
Yes, sir, completed.
Okay. So any doubt over here? Any clarification you want regarding any point?
Sir, non-polar covalent is one.
Non-polar covalent. Which number?
Sir, I want to understand the point.
Which point? Which one? Tell me. One, two, three, four. 4 point or 6 point.
Yes, the point.
Okay, see, the bond formed between two atoms is same electronegativity. If two atoms have same electronegativity, what is the meaning of the word electronegativity? Tendency to pull the shared electron. So if two mining atoms, it have the same tendency to pull the shared electrons, then what will happen? Neither of them will be able to pull the electrons. No, those shared electrons will remain in between. Okay, so they will not attain any charge. Electrons will go towards any of that. Because of that, the bond will remain non-polar. Clear?
Yes, sir.
Okay. But with slight electronegativity difference means one is slightly electronegative than the other. One has little more tendency to pull the shared electron toward itself than the other. Then what will happen? Shared pair of electrons will move slightly towards one of the atom, and that atom will acquire a slight negative charge, and the other atom will acquire a slight positive charge, and it will become polar in nature. So with slight electronegativity difference, atom will be polar covalent bond. But with high electronegativity difference means one is highly electronegative, other one is highly electropositive. And in that case, what will happen? The electrons will get transferred completely, no sharing of electrons. In that case, electrons will get transferred completely from one atom to the other atom. Okay, and the bond will become ionic in nature.
So, sir, the bond will become electrovalent. It will no more be
Yes.
covalent.
Yeah, no more the covalent. Clear?
Okay, sir.
Sir, please explain the
Yes,
fifth one
sir.
also.
Fifth one, okay. A polar covalent molecule is known as dipole molecule. Dipole means two ends. Polar covalent molecule has got two ends, one positive end and the other one negative end. That's why it is known as dipole molecule.
So how it has both positive and negative ends?
One positive and one negative end. Polar covalent molecule. For example, you see this one. Hydrogen chloride. Chlorine is more electronegative than hydrogen. So chlorine will pull the shared electrons toward itself. Because of that, it will acquire slight negative charge, and hydrogen will acquire a slight positive charge. So we have two end over here, positive end and the negative end, dipole molecule.
Okay, sir.
Yeah.
Yes, sir.
Sir, will you tell once more what is electronegativity?
Tendency, you have written, no, I made you write in that periodic properties. Tendency of an
Sir,
atom.
so that you will explain me later.
Tendency of an atom in a covalent molecule. Write it down there.
Sir.
Hmm. Why two people? What? Doubting?
The doubting chapter.
Which chapter? But let me explain this electronegativity. Tendency of an atom. Just a minute. Tendency of an atom in a covalent molecule to pull the shared electron towards itself. Okay, that is known as
Sir,
electronegativity.
electronegativity will be more in non-metals.
Yeah.
So, sir,
Not in all the nonmetals. You have to see, you have to consider the nuclear charge. You have to consider the nuclear charge. Please go through the notes that are given in the class. Okay.
yes, sir.
Get some get the note from somebody and then. Okay, so this is done. Okay, what was the doubt? What doubt you had in first chapter? Who's that? Who is having doubt in the first chapter? Sir, I. Okay, so what is that? The periodic property. Say quickly. Give me your doubt. All period. I have doubt. What's wrong with you guys? Say, say yes. What happened? You can write down your doubts, okay, in the chat box. That will write and answer. Now next we have condition for the formation of covalent bond. Okay, if there are two atoms, okay, what do they have? What are the requirements that they should possess? Okay, because of that they will be forming covalent bond. First one is both the atoms should have four or more electrons in their valence shell. That means there should be non-metals. Exceptions are hydrogen, beryllium, boron, aluminium. This beryllium, boron, aluminium, they don't have four electrons, they are metals, but they also form covalent compound. Okay, that you will understand in class, that you will class level because of some other that you are saying here. Okay. Next one is the first one. Just remember that both the atoms should have four or more than that electrons. Both the atoms should have high electronegativity. Both the combining atoms are having high electronegativity, then only neither of them will be able to means get the electrons completely. Okay, so they will share the electrons. Both the atoms should have high electronegativity. Like if you say that, means if you take the example of chlorine molecule, in chlorine molecule there are two chlorine atoms. Okay, so how is chlorine molecule formed? Chlorine molecule is formed by the sharing of one valence electron between two chlorine atoms, right? But both the chlorine atoms are highly electronegative. Both of them have got the same tendency to pull the electron. So because of their equal electronegativity, okay, they will not okay, they won't be able to pull the electrons toward themselves. Then both atoms should have high electron affinity. Electron affinity should also be high. Okay. Both the atoms should have high ionization energy. High ionization energy, they will not be able to lose their electron. Okay, rather they will require more energy to use their electron. Electronegativity difference between the combining atoms should be zero or invisible. Electronegativity, there should not be any electronegativity difference between the two combining atoms. Okay, otherwise one will become highly electronegative and the other will become highly electropositive. And because of that, complete round electrons will take place between them. So these are the conditions for the requirement for the formation of covalent bonds. Please write it down. Okay, it's 11 now. I'm giving you a break. Come after 5 minutes. Now, chapter. So, affinity. Okay, in case of electron affinity, actually, it is concerned with a tendency to gain electron. Now, when an atom, like metal, when it is gaining electron to achieve its chemical stability, that it has to release certain amount of energy. So the amount of energy that is released when an isolated atom gains electron in its outermost orbit and forms a negative ion It is known as electron affinity. Okay, the amount of energy released when an isolated atom gets electron in its outermost orbit and forms a negative ion, then it is known as electron affinity. Okay, electron affinity is concerned with an isolated atom at all. Electronegativity is the tendency of the atom in a covalent molecule, in the bonded molecule, not alone. That's the difference.
So what is isolated?
Isolated alone, bonded, unbonded atom. Okay, is it done?
Yes, sir.
Please write quickly.
Yes, sir, now done, sir.
Has everybody completed?
Yes, sir.
Okay. Now, you please open page number 29 in your textbook. Page 29. There we have structure of covalent compounds. Page number 29. Now, the structures. Okay, now I explained you, okay, I told you earlier that you will get only electron dot structure or structure, okay, no structure or ionic for the formation of covalent or ionic molecule. So here we have electron structure, okay, and this you will be practicing. So you just take it down in your chemistry notebook. So the first one is for hydrogen molecule. You can see over here electron dot structure for the formation of hydrogen molecule, that is here on page number 29. So this consists of two steps, and both the steps you have to draw. The first one is before combination. In that step, you can see two hydrogen atoms with their valence electrons are shown, and a plus sign is given in between. And after combination, both the electrons from hydrogen atoms will come in between two hydrogen atoms. Okay, that's what the sharing. Or you can also show it by a single line and then the hydrogen molecule. So please draw it in your chemistry notebook. Electron dot structure of hydrogen. Then I'll ask some questions. Please first to complete this one. Everything will go nicely so that you can understand later on. What is the total strength of the class? 50 student, no? What is your total strength? What is the total strength of the class?
Sir, 30.
No, now. Total number of students in this NC.
Sir,
So
51.
51.
51, no? Where are the 20s? You will understand chemistry by themselves. Later on, they will see that they have not understood, they have missed the class. Don't take these online classes lightly. Even these online classes are very important. You can understand everything if you pay attention. But if you miss the class, you miss all the important things from the important explanation. And later on, they will say that they have not understood certain concept. Okay, have you completed this electron dot structure of hydrogen molecule? Very simple. Just you have to understand the steps. Now, tell me the question. Okay, just give me the answer. The question is, how many shared pair of electrons? How many shared pair of electrons are present in hydrogen molecule? In one hydrogen molecule. How many shared pair?
Sir, one.
One shared pair, no, one shared means two electrons. Okay, and if I say total number of electrons present in one hydrogen molecule,
Sir, two.
two electrons. Okay, so question will be asked in this way also. So you have to understand. If you know the structure well, you can give the answer. Next one we have electron dot structure of chlorine molecule. You can see the page. There also there are two steps before combination and after combination. In the before combination, you can see there are two chlorine atoms, both with seven electrons. Okay. After combination, will come close to one another with two electrons in between them, and the remaining will be there. So just draw it. Fast. Uh, okay. Now I'll give the answer to this question. Now tell me how many lone pair of electrons? How many lone pair of electrons are present in chlorine molecule? How many lone pair of electrons? Hmm? Chlorine molecule.
Oh, sir, one.
One. Lone pair of electrons. I said lone pair of electrons.
Sir, one.
Do you know the meaning of lone pair of electrons?
Sir, three.
No, sir.
Don't know the meaning of lone pair of electrons.
No, sir.
Lone pair of electrons, you write it there in bracket. Lone, L-O-N-E. Lone pair of electrons means unshared. Unshared pair of electrons. The electrons which remains unshared.
So,
Those
sir,
are the correct answer. No, 7, 6.
Sir,
Each
how?
chlorine atom, see, each chlorine atom, okay, you see that in after combination, each chlorine atom has got three lone pair of electrons which are unshared. For two chlorine atoms, 6, no.
Sir, how it will be three?
Pay attention. See, in the formation, okay, initially chlorine atoms, they have got 7 electrons. Okay, each chlorine atom has got 7 electrons. Now in the formation of chlorine molecule, both the chlorine atoms will share electrons. So one from each chlorine atoms. Okay, that is shared. So one shared pair of electrons. So remaining 6 electrons. Remaining 6 electrons of each chlorine atoms will form pair. No. Okay, so
Yes.
three pair. There will be 3 pairs. Okay, so 3 lone pair of electrons for each chlorine atom. So altogether 6 lone pair of electrons. Okay, so keep that in mind. So a chlorine molecule has got one shared pair of electrons and 6 lone pair of electrons. Okay, in chlorine molecule atom. But if you take chlorine atom, okay, chlorine atom has got all unshared electrons, one pair of electrons. So that is for hydrogen molecule and chlorine molecule. Next one, you come to next page, page number 30. In page number 30, we have electron dot structure for oxygen and nitrogen atom. Please go it quickly. Now tell me how many valence electrons are present in oxygen atom? How many valence electrons are present in oxygen
6.
atom? 6. Okay. 6. So how many electrons they require? Electron configuration?
4.
Sir,
2.
two.
So they will share 2 electrons. So there will be 2 shared pair of electrons and 4 lone pair of electrons in oxygen molecules. Beautifully.
2 will be the right answer.
Okay, have you completed oxygen molecule? Now move to nitrogen molecule. Okay, go to nitrogen also. Nitrogen molecule, electron dot structure. So you may get posted test on that. Okay, after completing that, you come to carbon tetrachloride. Electron structure of carbon tetrachloride, and then we have methane molecule. Do it quickly, we are left with 5 minutes only. And if you have any doubts regarding this, you can ask questions. And three pair of electrodes. So these things you have to keep in mind. Okay, because yes.
The oxygen will have one pair now.
How one here and how it is? Two oxygen atoms inside. How many valence electrons are present in oxygen atom?
6.
6. So how many electrons they require?
2.
Okay, so both the atoms will share two electrons. No? So if they share two electrons, there will be four electrons altogether. So four
Yes.
electrons means two shared pair.
So sir, I want to ask that one atom will have one oxygen atom will how many lone pairs?
Just see. The three lone pair of electrons. One oxygen atom has got 6 electrons in their valence shell. No. So 6 electrons in the valence shell means three lone pair of electrons. 6 valence electrons means.
Yes, sir.
So after completing oxygen and nitrogen molecule, you come to carbon tetrachloride and then methane. Only the electron dot structure, no orbit structure. Please do it quickly. Okay, please complete carbon tetrachloride also quickly. In carbon tetrachloride, we have 4 chlorine atoms. That surrounds carbon atom. Okay, so just tell me in carbon tetrachloride, lone pair of electrons are present on the carbon atom. In carbon tetrachloride, tell me how many lone pair of electrons are present on carbon atom?
6.
Huh? In carbon tetrachloride.
So 0 net bond.
Carbon tetrachloride. I'm asking about carbon in carbon tetrachloride. How many lone pair of electrons are present on carbon atom? in carbon tetrachloride.
Pair of electrons.
Two lone pair of electrons on carbon atom. Carbon atom has got four valence electrons. No, so those four valence electrons will be shared each one with four chlorine atoms. So it is just zero lone pair of electrons. No, all the four electrons are shared. So it has zero lone pair of electrons. I am not asking about chlorine molecule or the carbon tetrachloride molecule as a whole. Only the carbon atom. The carbon atom will have no lone pair of electrons because all the four electrons are shared with chlorine atoms. Is it clear?
Yes, sir.
We don't have any confusion because questions will be asked. I am just clarifying all these things so that you can understand. Question will be asked based on all these things. If you have confusion, if you have not understood till now, please ask. Then after that you complete methane molecule also. Methane molecule. In methane molecule we have hydrogen, okay, in place of chlorine, and the structure will be same. Both atoms will share one electron each. Okay, if you have completed this methane molecule, you can leave the class. It's time 11:26.
Sir, excuse me.
Yes.
Sir, chlorine will have how many lone pair of electrons?
Chlorine atom alone or in carbon tetrachloride.
Chlorine atom will have?
In which means alone are asking or that means in carbon tetrachloride.
Carbon tetrachloride.
In carbon tetrachloride, each chlorine atom will have three lone pair of electrons because one will be shared. No, one chlorine atom has got seven valence electrons. So out of seven, one will be shared with carbon atoms. So each chlorine atom will be left with six electrons, six valence electrons. So six valence electrons means three lone pair of electrons. Clear?
Sir, three lone pair of.
Yeah, three lone pair of electrons. Each chlorine atom.
Okay, sir. Then it will be 12 pair of.
Yes, total 4 pairs, 12 pairs.
Sir, I have a doubt.
Okay, sir.
Sir, in oxygen molecule, there may be two atom, three atom, four atom, and seven atom. How is this possible?
Hmm? No, one oxygen molecule will have two atoms only.
Sir,
Right is so. If you take one oxygen atom, it has got how many valence electrons? Six valence electrons. No,
yes,
it
sir.
has got six valence electrons. That means it requires two more electrons. Now for those two more electrons, it needs one more oxygen atom. If you take one more oxygen atom, so both the atoms will share their electrons and they will achieve stability. Okay, so two atoms are enough for providing chemical stability.
Sir, but ozone molecule.
Okay. Ozone that is formed by coordinate bond. Okay.
Okay.
Ozone molecule. When one more oxygen atoms comes, then you can see these oxygen atoms still have lone pair electrons. So those lone pair of electrons will be provided to the okay.
Yes, sir.
Then oxygen molecule will form. That we will do in coordinate bond. Okay.
Okay, sir.
This is coordinate bond will when one of the atoms will share the lone pair of electrons and not both the atoms. You can leave the class. It's fine.
Thank you, sir.
Leave the class will